We are already familiar with these four algebraic identities because we have studied this in our grade 8 mathematics, right? So first one was x plus y whole squared is equal to x squared plus 2xy plus y squared. The next one that we studied is x minus y whole squared is equal to x squared minus 2xy plus y squared. Then x squared minus y squared is equal to x plus y and multiplied by x minus y. And then x plus a multiplied by x plus b is equal to x squared plus a plus bx plus ab. Okay, so you should know all these four algebraic identities, and we have solved many problems based on this. Okay, now let's add four more identities to our memory bank, and the fifth one is x plus y plus z whole squared is equal to x squared plus y squared plus z squared plus 2xy plus 2yz plus 2zx. Okay, now in this particular video tutorial, we'll only focus on identities and their proofs. And in our next video tutorial, we'll discuss problems based on identities. And they are mainly related to factorization of polynomials using these identities. Okay, now x plus y plus z whole squared. What we can do here is we can take x plus y as, let's take x plus y as t. So if you take x plus y is equal to t, then this algebraic expression is actually t plus z whole squared, right? So from here you get t squared plus 2tz plus z squared. Clear? Now this is t squared. It means that now we can write it as x plus y whole squared plus 2 at the place of t, right? X plus y and then z, then plus z squared. Now from here you can write this as, now it is of the form x plus y whole squared. This identity you will use here. So it becomes x squared plus 2xy plus y squared, and from here you get 2xz. We can write it as like xz plus yz plus z squared, and this becomes x squared plus 2xy plus y squared, and this is 2xz, then you have 2yz, and then you have z squared. Let's rearrange it and rewrite it as x squared plus y squared. We are bringing this z squared here, and then you have this 2xy, and then you have this 2yz, and then you have this 2, it's xz, so you can write it as 2zx, because it is basically 2 multiplied by x multiplied by z, so it's nothing else but 2 multiplied by z multiplied by x. So it's like in a rhythm, x squared plus y squared plus z squared plus 2xy plus 2yz plus 2zx. So this is basically what we had to prove, and this is x plus y plus z whole squared. Remember it, we'll use a lot when we'll solve problems based on factorization. Next you have x plus y whole cubed, and this is actually equal to x cubed plus 3x squared y plus 3xy squared plus y cubed, or you can rewrite it as x cubed plus y cubed plus 3xy multiplied by x plus y. You have to remember both these. Okay, so we can use either this one or we can use this one. Okay, both of these expressions will be used when we'll solve problems. And now let's see the proof. This is x plus y whole cubed. So this is actually x plus y multiplied by x plus y whole squared. Any problem? Because x plus y multiplied by x plus y whole squared gives you x plus y whole cubed, the exponent one, like a multiplied by a squared is equal to a cubed. Same thing is here. Okay, now this becomes x plus y this is x plus y whole squared. So this is x squared plus 2xy plus y squared. Now, using distributive property of multiplication or addition, first take x and multiply this with by x squared plus 2xy plus y squared, and then take this y and then multiply it by x squared plus 2xy plus y squared. From here you get x cubed, then you have 2x squared y, then you have x y squared, then you have y x squared, then you have 2x y squared, and then you have plus y whole cubed. Right? Now, this is x cubed plus, let's bring this y cubed here. Now, plus, this is 2x squared y. So this 2x squared y and this yx squared, both these two are like terms because this is x squared y and this is yx squared. It means that it is x squared y only. Right? So variables are the same. So this is 3x squared y. In the same way, here we have xy squared and here you have 2xy squared. It means that it is 3xy squared. These are like terms. Right? Now, we have proved it actually. We can write it as x cubed plus 3x squared y plus 3xy squared plus y cubed. We have simply rearranged it, this one. So basically this is what written here, and if you take this one only and you write it as x cubed plus y cubed, now plus this is 3x squared y and this is plus 3xy squared. Let's take 3xy common, applying distributive property of multiplication over addition. This is x plus y. Any problem? So this is what written here. So remember both this algebraic expression also and this one also. This is the expansion of x plus y whole cubed. Okay. Now, similarly, you have x minus y whole cubed is equal to x cubed minus 3x squared y. Remember it. It's minus 3x squared y, but it's plus 3xy squared and then minus y cubed. Right? So here it was plus, so it was all plus, but when it is x minus whole cubed, so x cubed minus 3x squared y, but only this term will be plus 3xy squared minus y cubed. But when you write it in this form, it's all minus x cubed minus y cubed minus 3xy minus multiplied by x minus y. And its proof will be quite similar to this one. In this case, this is x minus y whole cubed. So we can write it as x minus y multiplied by x minus y whole squared, right? And this is the identity 2. So x minus y, then this is x squared minus 2xy plus y squared. And now applying distributive property of multiplication, So from here you get x, and this is x multiplied by x squared minus 2xy plus y squared, and then you have minus y, x squared minus 2xy plus y squared. So this is x cubed minus 2x squared y plus xy squared, then you have minus yx squared, then you have plus minus multiplied by minus is plus 2xy squared, and then you have minus y cubed, right? Now this is x cubed, this is minus 2x squared y, and this is minus yx squared. Like terms, it's x squared y, it's also x squared y. So this is 3 minus 3x squared y, right? Then you have this xy squared and you have plus 2xy squared. It means that it is 3xy squared. Can you see that you have plus sign here? And then you have minus y cubed. So this is what we have written here. And in order to get this one, what you can do is simply write this as x cubed and bring this minus y cubed ahead, and then you have this one. So this is minus 3x squared y plus 3xy squared. If we take minus 3xy as common, then inside you'll have x minus y, distributive property of multiplication or subtraction, right? So this is what we have written here. Now if you're getting confused in how we have written this, so it's very easy. This is minus 3 multiplied by x multiplied by x multiplied by y. This is plus 3 multiplied by x multiplied by y multiplied by y, right? Now this 3, this x and 1 y, this 3, this x and 1 y, these are same in both these two terms, common. So let's take this out and let's take out the minus as well. So you put minus and then 3xy, then within the bracket you have now x, and then now since you are taking minus outside the bracket, you have x minus y, right? So you have x minus y. So this is what we have written here. Now this is last one, and in this identity we have x cubed plus y cubed plus z cubed minus 3xyz. This is equal to x plus y plus z multiplied by x squared plus y squared plus z squared minus xy minus yz minus zx. You have to learn this, but let's see the proof of it. So this is x plus y plus z. Let's write it here, x plus y plus z multiplied by x squared plus y squared plus z squared minus xy minus yz minus zx. Now you can multiply by distributive property of multiplication over addition. So this is x multiplied by x squared plus y squared plus z squared minus xy minus yz minus zx, then plus this y, then you have x squared plus y squared plus z squared minus xy minus yz and minus zx. Then you have this z here, so plus z multiplied by x squared plus y squared plus z squared minus xy minus yz minus zx, right? Let's multiply it. So you get x cubed plus xy squared plus xz squared minus x squared y minus xyz minus zx squared. Then you have plus yx squared plus y cubed plus yz squared. You have minus xy squared. Then you have minus y squared z. Then you have minus zxy. Then plus you have zx squared plus zy squared plus z cubed minus zxy minus yz squared minus z squared x, right? Okay, now take this x cubed, y cubed and z cubed. Write it here, x cubed plus y cubed plus z cubed, right? Next you have this xy squared, and then you have minus xy squared plus xy squared minus xy squared gets cancelled, right? Next, you have x z squared, and you have another, this is plus xz squared. Here it is minus z square x. Both are the same. X multiplied by z squared is actually nothing else but z squared multiplied by x. Both these two are same, right? So plus and minus, this also gets cancelled. Now you have minus x squared y, and you have plus y is x squared y x squared, both are same. X squared y minus plus, this also gets cancelled. Then you have minus z x squared, right? So minus z x squared plus z x squared, both these two get cancelled. Then you have plus yz squared, and you have minus yz squared, plus minus gets cancelled. Then you have minus y squared z, and you have plus zy squared, y squared z, that is zy squared, same. So plus minus gets cancelled. Now you have minus xyz minus zxy, same, xyz, and minus zxy means same, xyz. So minus, that is minus 3xyz. And that's what we have here, and we have proved it. So eighth one, it's very easy to remember. Only thing is, sometimes students make mistake in this one. When they actually write this particular expression, they usually put minus here. Don't make that mistake. It's x cubed minus 3x squared y plus 3xy squared minus y cubed. But when you write in this form, then before every term you have minus, except this initial one, right? So remember this one. In our next video tutorial, we are going to discuss some problems based on this.